let me give you an example of a 3-port network just to show you how can we really analytically calculate those S parameters. So if I do take now the S matrix I gave you before, and I basically spell out the exact equations, you will find out, for example, that B1 is equal to S11A1 plus S12A2 plus S13A3, and so on for B2 and B3. So it doesn't really take much to realize that if I want to calculate any of those parameters, then I have to apply some conditions. For example, if I want to calculate the S11 parameter right here, then I can simply say that S11 will be equal to B1 divided by A1, provided that I can make A2 and A3 to be equal to 0. And that's a direct consequence, obviously, of the equation. Similarly, if I want to calculate S21, which is the parameter that you see on the second equation right here, then S21 will also be equal to B2 divided by A1, provided that you can make A2 and A3 to be equal to 0. And so on and so forth. So you can always impose some conditions on the A waves, on the instant waves, to essentially get an equation that will give you the S parameter that you want. Typically, we calculate all S parameters for a network, and so we have to go through this process basically for all numbers. Now, you may ask the question, how can I really make sure that A2 and A3 are equal to 0? In other words, if I look at the figure here, how can I make sure, for example, that this AN is equal to 0 or this A2 is equal to 0? Well, this is actually done really easily, both in real life and measurements as well as analytical calculations, by properly terminating the port. For example, if I go ahead in port N and I terminate the port with its characteristic impedance Z0 N, then any potential Bn that may be propagating down here will essentially return 0 because there will be no reflection. Similarly, if I go to port 2 and I basically terminate this port with its own characteristic impedance, Z02, then again, any propagating wave B2 that may hit that impedance will basically return a 0 wave back simply because I have no reflection. And that's exactly what we do in real life. When you go and make a measurement in a network and let's say you want to measure S11 or S21, you will go and terminate the characteristic impedances, the ports with their own characteristic impedances to make sure that these devices will give you an A2 and A3 of equal to 0. And as you will see in just a minute, we'll do exactly the same thing when we need to analytically estimate them.